wasn't recording. Okay, so everything I've said about this so far is grand. All of those black lines, the printed lines, are 2A because they're 4 equilateral triangles. Then what I was saying about the circumcenter makes those 3 radii the same. We don't know what they are. We need to figure out what they are. And then we have the yellow one, which represents the height. Yeah? Now, it's kind of hard to draw this, but like this... this to this, this to this, and this to that, see what I mean, is a full circle that adds up to 360. So if we do 360 divided by 3, it means each one of them is 120 degrees. Ugh. Okay, I'm just going to try and write into this one. Yeah, so that's 120 degrees. Now, because both of these pink sides, like this one here and this one here, make up that triangle, it's an isosceles triangle. So if it's isosceles, it means the two base angles are the same. So we can do 180 minus 120 to get 60, and then divide that by 2 to get 30, and basically that's 30, and that one's 30. Yeah? So if I just redraw that little triangle rather than redrawing the whole thing, I have that this is 120, this is 30, this is 30, this is x, and this is 2a. And we're trying to figure out what x is, yeah? So it's not right angled, and we don't have the cosine rule things. We don't have all 3 sides, and we don't have 2 sides in the angle in between. So it has to be sine rule. So sine rule is pick a side and take the angle opposite. So x over the sine of 30, and then pick a side and get the sine of the angle opposite. So, sorry, I just did that completely backwards, but you know what I mean. Pick a side and take the sine of the angle opposite. So it's 2a over the sine of 120. And then we're trying to isolate this, so I'm going to multiply by sine 30, which will cancel that out, and then I'm going to multiply here by sine 30. So that gives me, the 2a is what it is, so sine 30 divided by the sine of 120. So I kind of want it as a sine 30 bracket over 120. No. Okay, so it's not going to, I need it in surd form because of this. So I'm going to have to use my formula and tables book to get it in surd form. So let's see. Sine of 30, if I go to my formula and tables book, I get sine, I'm on page 13. The sine of 30 is a half. And then the sine of 120. Now the sine of 120, I'm going to have to draw that one because that's not one of the special angles. So where's 120? 120 is like here somewhere. Yeah, so what I'm actually looking up is 60, and it's in a quadrant where sine is positive. So it's just going to be the same as the sine of 60. And the sine of 60 is root 3 over 2. So this by this is just 1, so that's just a. And then root 3 over 2. And then I can KFC this because I'm dividing by a fraction. So, sorry, I can KFC that because I'm dividing by a fraction. So it's a multiplied by 2 over root 3. And then if we top by top, bottom by bottom, it's 2a over the square root of 3. Yeah? And that's the radius. And then I can pull out that other triangle. So I can go like this. So that triangle is this one. Does that make sense? So I now know that x is 2a over the square root of 3. This is the height, which I don't know, and I know that this is 2a because that's one of the original equilateral triangle, and this is right angled. So I should be able to just Pythagoras this. So c squared equals a squared plus b squared. 2a squared equals 2a over the square root of 3 squared plus h squared. I have 4a squared, square the 2, square the a, and then I have 4a squared over 3 plus h squared. I'm going to minus 4a squared over 3, and I'm going to minus 4a squared over 3. So I have 4a squared minus 4a squared over 3 equals h squared. Now these are both a squareds. Do you know, like they're both in the same family. So I can just do 4 minus 4 over 3. And I get 8 over 3. Oh, I think there was an 8 in it, wasn't there? So I get 8 over 3 a squared equals h squared, and then square root. So that gives me the square root of 8 over 3, the square root of a squared, and that equals h, which is the square root of 8 over 3. This is just a, and that's h. Yeah? Okay. So I said at the start I was trying to fill this in. So I might just go up there and fill it in actually. So it's pi, or that was this here, see it there? 2a over the square root of 3 squared. And then h, I just got there, is the square root of 8 over 3a. Okay, so I'm going to square this first, and then I'm going to go back and look at what I'm trying to get. So this is 4a squared over 3, and then I have the square root of 8 over 3a. Now, so it has the pi and the a cubed at the end, and then just the numbers at the start. So I'm going to take this and then these to the end and just bring the numbers together. So it's 4 over 3, and then it's the square root of 8 over 3, and then pi a cubed. I'm just going to type that into my calculator and see what happens. So 4 over 3 bracket square root of 8 over 3 close bracket. Oh no, close bracket. 8, that's right, 8 root 6 over 9. Perfect. And then pi a cubed. So that's that one. Is that all questions you want? Sorry, I don't mean that. I mean, was there any other parts? I don't think there was. We'll have a quick look at question 3. Back to algebra. So find the set of real values for which. So this is just an inequality. And it's a quadratic inequality, so we just have to solve it. I might guide number this one. So the guide is minus 30. So 1 by 30, 2 by 15, 3 by 10. I am looking for a 1. Oh, 5 by 6. I need a plus 1, so minus and plus. So that is 2x squared plus 6x minus 5x minus 15 equals 0. I will deal with the inequality in a second. Pair it up. So I get 2x and x plus 3, and I get minus 5 and x plus 3. So that is 2x minus 5 and x plus 3. Yeah, then I need to solve. So 2x minus 5 equals 0, and x plus 3 equals 0. So plus the 5 minus the 3 minus the 3. So So I get 2x equals 5, and I get x equals minus 3. And then divide by 2, divide by 2. So x equals, that's 5 over 2, or 2.5. It's an inequality, so I need a range, so I need to sketch it. So 1, 2, 3, there's minus 3, and 1, 2, 3, there is 5 over 2. To my sketch, that's horrific. So I'm going back over here, and I'm looking for where this is, see up here? Yeah? I'm looking for where it's greater than 0. So greater than 0 is here and here. So this scribbling is on the left of minus 3. So x is less than or equal to minus 3. And this scribbling is on the right of 2.5. So x is greater than or equal to 2.5. And then just make sure there was no eliminated solutions, which there wasn't. So there are my answers. I honestly don't know what scheme I printed. This also doesn't line up with my scheme. Who knows? Anyway, obviously if I have any of these wrong, I'll come back to you. The 3 simultaneous then, I heard loads of people complaining about this. So we want to take first line and second line. Now I can see an immediate problem with the second line in that it has fractions, so I'm going to multiply by 2. So x plus y plus z equals 16. Multiplying by 2, I get 5x plus 2y plus 20z equals 80. So top line by minus 2, I'm going to cancel the y's. Yeah, so minus 2x minus 2y minus 2z equals minus 32. 5x plus 2y plus 20z equals 80. Gone? So that is 3x plus 18z equals, don't trust my maths, 48. Yeah? Okay, and then I'm going to take middle and bottom. So I'm going to take the middle one without the fractions, which is 5x plus 2y plus 20z equals 80. And same with the bottom line, actually. It's got a 2, so I'm going to multiply by 2. So that is 4x. Sorry, it's behind again. 4x multiplying the half by 2 just gives me y. The 4z becomes 8z, and the 21 becomes 42. I cancelled the y's last time, so I have to cancel the y's this time. So bottom line by minus 2. So top line unchanged, 2y plus 20z equals 80, and the bottom line is minus 8x minus 2y minus 16z equals minus 84. 84. Yeah. They're gone. So I get minus 3x plus 4z equals minus 4. Okay, and I'll throw these two together. So 3x plus 18z equals 48. Oh, minus 3x plus 4z equals minus 4. So these cancel without any work. Nice. 22z equals 44. Divide by 22, divide by 22. Z is 2. Okay, take the top line. 3x plus 18z equals 48. 3x plus 18 times 2 equals 48. 3x plus 39. What am I doing? Oh no, sorry, 18 times 2. 36. Equals 48 minus 36 minus 36. So 3x equals 12. Divide by 3, divide by 3. So x is 4. And then I'm going to go back to the top line. So x plus y plus z equals 16. X plus y plus z equals 16 is 4 plus y plus 2 equals 16. Y plus 6 equals 16. Minus 6 minus 6. Y equals 10. Oh, sorry. And again, I don't know if I have the solution. I cannot. Of course I don't. Okay. I might try and get this one done. Don't know if I get this one done, but I'll try. So a Ferris wheel has a diameter of 120 meters. Sorry, let me check if this is my question. When it is turning, it completes exactly 10 full rotations in 1 hour. I don't know if I'm going to care about this, but I'm going to do it. So 10 rotations in 60 minutes, which means 1 rotation in 6 minutes. Sorry. Okay. The diagram shows the Ferris wheel before it starts to turn. At this stage, the point A is the lowest point in the circumference of the wheel and is at a height of 12 meters above the ground. The height h of the point A after the wheel has been turning for t minutes, okay, is given by that, where h is in meters, t is an element of r, and pi over 3t is in radians. Okay, so I'm going to try and type this in using my, hang on, angle unit is 2. It's in radians. Okay, so I have 72 minus 60 cos pi over 3 x, oh no, delete, x bracket. Okay, so what I have in my calculator looks exactly like what's there, except instead of t I have x. Yeah? Okay. Sorry, I didn't do it properly. So 72 minus 60 cos shift pi over 3 arrow alpha x close brackets. I want to start at 0. I want to end at 8. And I want to go up in steps of 1. Okay, so this is giving me 12, 42, 102, 132, scrolling down, 102, 42, 6. 6 is 12, 7 is 42, and 8 is 102. Okay, I literally used the function calculator there and made sure my calculator was in radians, and I just typed that straight in. Okay, draw the graph. Okay, so hang on. No, I'll leave that here. Okay, so 0 is 12. That's 10, so there-ish. 1 is 42. We're just going to do it this way. Pen. 1 is 42, so that's going to be like there, a little bit above. 102 then for 2. 102 is going to be like there. 132. That's 130, so that's 132. Back to 102. There. 5 is 42 again. So that's there. 6 is 12 again. There. 7 is 42 there, and 8 is 102. 102 is there. Okay, so you can clearly see the shape. Now, whether I can draw it is another story. Oh, like that? Yeah? Okay. So, yeah, that's fine. So the period is how long it takes to complete one full revolution. So it started at, it started at 0 and the height was 12. So we basically want to know how long did it take before it got to 12 again. And that was 6. Yeah, so 6. And then the range, the lowest point to the highest point. So it's going to be 12 and then 132, I think is the highest. So that's 12 and 132. During a 50-minute period, what is the greatest number of minutes for which the point A could be higher? Oh. Sorry, I think that is a calculus question, which you haven't done. So I think that one's going to have to be removed. By solving the following equation, find the second time, the second value of t, that the point A is at the height of 110 after it starts turning. Did we do this one in class recently, or did we do something similar? So minus 60 cos pi over 3t. Sorry, what I'm doing is I'm moving this over. I just didn't write it. So that equals, I think we did this. That equals 38. And then what I'm going to do is I'm going to divide by minus 60 on both sides. So that's that, right? That is an equation that I need to solve. And in order to solve it, you have to use the cast circle. So I'm going to get the reference angle by doing inverse cos of 19 over 30. Oh, do you know what? Sorry. I need to put this back into degrees. So inverse cos of 19 over 30, yeah, that makes more sense, is 50. So it says 50.7, so I'm going to just make that 51 degrees. This is definitely the one we did in class. So CAST. According to this, I am looking for where cos is negative. So that's these two over here is where cos is negative. So I work off this line and I'm going to make a 51 degree angle here and a 51 degree angle here. So the top one is 180 minus 51, which is 129, and the bottom one is 180 plus 51, which is 231. Okay, now provided the angle is just theta or t or x or whatever, you're done, but it's not. It's this yoke. Yeah, so we need to go pi over 3t equals 129 degrees and pi over 3t equals 231 degrees. Now, I can't actually do this because this is radians, and they're clearly degrees. So I need to either convert the degrees into radians or the radians into degrees. I'm going to go this way because this is easy. They're just 60, so I'm going to do that. So 60 degrees T equals 129 degrees, and 60 degrees T equals 231 degrees. So I'm going to divide by 60, divide by 60, divide by 60 the whole way across. So here I'm getting 129 divided by 60 is 2.15, and 231 divided by 60 is 3.85. Okay, so that means the first time that this thing was at 110 should have been at 2.15 degrees. So if I look at my, where's 110? Okay, if I put in a line for 110, hang on, doing red, insert a line. So 110 is there. Yeah, so the first time it's at 110 is like that point there. Yeah, and if you reference that down, that does look like it could be 2.15. And then the second time it's at 110 is there. And what was my second number? What was my second number? 3.85. So does that work? Yeah, just before 4. So that's the answer, 3.85. So by solving the equation, find the second time that it was at 110. There you go. Okay, grand. And then the last one, which I also assume is not on my screen. Like, it's actually not. Sorry, I just want to double check I'm not doing. Tetrahedron, yeah. The Ferris wheel, yeah. Ferris wheel. Yeah, the airplane. Okay. So, sorry. It's just my scheme that's completely wrong. Right, we'll do the last one. So, okay. An airplane flies east from point A for 2 hours at a constant speed of 420 kilometers per hour until it reaches B. Okay. Oh. Until it reaches B. It then changes direction and by heading 20 degrees towards the south at the same speed until it reaches point C. So the speed's the same. Down here. The direct distance from A to C is 1450, which is in the picture, and the angle is 8.57. Find how long it took to fly from B to C. Okay, so the fact that it's asking for how long means it's looking for a time. But everything else is distance and speed, so it feels like, no, I don't know, but it feels like Dad's silly triangle. At some point, I'm going to have to do time equals distance over speed. So the bit they're asking me for is this yoke here. That's way too big, sorry. So the bit they're asking me for is that bit there, yeah. I have the speed. I clearly don't have the time because that's the question. So what I need to do is figure out the distance, right? Okay, I actually think, okay. This angle here I can figure out because that's a straight line and the other side is 20. So that means that one has to be 160. So I think I can do a sine rule. So I can do 1450 divided by the sine of 160 equals x over the sine of 8.57. Okay, let me explain that. So there's the side, and you put that over the angle opposite. And then this side over here, right, which I realise has a speed on it, but we don't know the distance. So that's x. And then that x, if I highlight it, goes over the opposite angle, which is your 8.57. Yeah. So then I want to isolate this. So I'm going to multiply by the sine of 8.57 to cancel and multiply by the sine of 8.57 to balance. So x equals the sine of 8.57 multiplied by 1450 divided by the sine of 160. So I have 631.762 and it goes on. So I'm just going to store it. So I'm going to store A there just so I have it. Yeah? So I think that's the distance from B to C. So then I do time equals distance over speed. The distance is 631.762, blah, blah, blah. The speed was 420 because that's what they told me. So I'm going to divide that by 420. To the nearest minute. Okay, so I'm getting 1.504 and again it goes on, but that's hours. So I'm going to need to multiply that by 60. So that is giving me 90.25 minutes, which is 90 minutes to the nearest minute. Okay. That all right? The average fuel consumption in the plane is 3.8 litres per second and the fuel capacity of the plane is 100,000 litres. Show that the plane will be able to complete the journey from A to B to C directly and back to A, at a speed of 420 without refueling. Okay. Right, we're giving it per second. I need to know how long. Yeah? Don't I? For 2 hours instead. Okay. So from A to B is 2 hours. From B to C, that's an arrow, is 90 minutes. Do we know A to C? No, but we can figure it out. Sorry, not A to C, C to A. So C to A is 1450 at a speed of 420. So that's giving me 3.45 hours, which I'm going to multiply by 60. Oh no, I'm not, sorry. So it's going to be 3 hours. And I'm going to multiply the 0.45, by 60. So that's 27 minutes. Back to A at a speed of, okay. So that means the entire journey is 2 hours plus 1.5 hours plus 3.45 hours. Can I just do that? So the total journey is 6.95 hours. And it does 3.8 litres per second. Okay, so that means multiply that by 60. No. So that is 228 litres per minute. Yeah. And then by 60 is 13,680 litres per hour. And then we have 6.95 hours. So that is 95,076 litres for the journey. 95,076. How much do they have? The fuel capacity of the plane is 100,000 litres. Show that the plane will be able to complete the journey. It will. It'll have just under 5,000 litres spare.